So here I will give you a short video concerning the development of BET isotherm. As we said for the assumptions, that even by developing the BET isotherm and the science said that Langmuir assumptions are not correct, but by the end they was obliged to use or to apply Langmuir over each layer of adsorption to be able to develop their isotherm. So if we consider that we have our substrate here, our substrate, we have specific sites where the adsorption will take place. So here, once the gas molecules get adsorbed on the surface, they occupy the sites theta 0 over the surface and form the first layer. And here the sites over the first so the empty sites over the substrate where these gas molecules are adsorbed form the fraction of sites on the substrate, which are the theta 0, and the molecules adsorbed over the substrate became on themselves a substrate for other gas molecules, which will be able to adsorb or to condense over these molecules, forming the second layer. So here the first layer molecules became as support for the second layer, and thus we have a fraction of specific sites over the surface layer, which are theta 1, and also over this layer other molecules were condensed, forming the third layer, and here also they are adsorbed over the specific sites where we have theta 2, here we have theta 3, and for the infinity of layers I, we will have theta I. Okay, so if we apply now Langmuir over each of these layers, and we will consider first the adsorption over the substrate. So as we have solid plus A, if you remember the Langmuir isotherm, S plus A will give us SA. So here the adsorption over the substrate will be for the first layer Q1 adsorption times P of the gas molecules times theta 0, the fraction of sites over the substrate where the adsorption will take place, the desorption will happen from the first layer, from the molecules already adsorbed over the surface. So here we have theta 1 equal K1 adsorption over K1 desorption times P times theta 0. If we do the same thing for the second layer adsorption, so the adsorption will take place over the new substrate اللي هو صاروا هلا theta 1 equal K2 desorption times theta 2, and this way theta 2 will be equal K2 adsorption over K2 desorption times P times theta 1. If we extend this adsorption till the I layer, will determine theta I equal Ki adsorption over Ki desorption times P times theta I minus 1. Now we'll try to develop as all these factors, يعني مع كل each step of adsorption we will determine all these rate of adsorption, rate of desorption at each step or at each covered layer. So we will try now to use the BET assumptions to develop specific formula of theta 0. So if we use the assumption saying that the adsorption of first layer molecules is different from all the other layers, because the first layer, concerning the first layer, the molecules are directly adsorbed over the substrate. The other layers, we have molecules that get condensed over the previous molecules. So starting from I equal 2 and I more than 1, and after the formation of the first layer, here all molecules are condensed over the surface. So all these molecules are adsorbed over same molecules and not over the solid. So the mechanism of absorption is almost the same for all the others layers. So K2 absorption over K2 desorption times P will be the same over KT over K3 absorption over K3 desorption, and will be the same of Ki absorption, Ki desorption times P, as all these layers are of condensed gas molecules over the first adsorbed layer. So BET scientists correlate this K2 absorption, K2 desorption till Ki over Ki absorption and desorption times P, and define it as factor X. Now we will try to correlate this X with the first layer. The first layer, we determine that theta 1 equal K1 adsorption over K1 desorption times P times theta 0. So as we have the same gas molecules, somehow K1 adsorption over K1 desorption times P should be similar to X with different specific factor اللي هو C. So هيدا البارامتر هو similar to previous one. The difference بيناتهم إنه here we have adsorption, and thus BET science defined the Q1 adsorption over Q1 desorption times P as Cx, where C is a factor dependent on delta H adsorption minus delta H condensation, or L over RT. So this C factor, it's a factor of BET isotherm, is directly correlated with the enthalpy of adsorption of the first molecules over the substrate. So by increasing enthalpy of adsorption, C increases, and thus the coverage over the surface will increase. Now, if we want to try to correlate all the thetas, or to develop theta I as function of theta 0. So we have theta 1 equal Cx theta 0, and theta 2 equal X theta 1 لأنه هي equal K2 over K2 times P times theta 1, وهيدا الفاكتور كله هو X. So if we put theta 1 by its value, theta 2 will be equal to Cx square theta 0. Okay. So if we determine theta 3, it will be K3 adsorption over K3 desorption times P times theta 2. So here X theta 2, here if we replace theta 2 by its value, say Cx3 theta 0. So thus we'll be able to determine theta I as Cxi times theta 0, and by this way we determine a correlation between theta I and theta 0 as function of C and X power I. Over the surface, if we look over the surface, all these fractions of thetas will form the total surface, or the total quantity of molecules which are adsorbed over the surface. Here, if we determine the total now, the total surface will be summation of theta I, and as theta are fractions over the surface, fraction of sides over the surface, a summation of theta I will equal to 1. If we replace all thetas by their values, so summation of theta I equal 1 will give us theta 0 plus theta 1 plus theta 2 plus theta I equal 1. So theta 0 plus Cx theta 0 plus Cx2 theta 0 plus Cxi theta 0 will be equal to 1. Here the aim is to determine theta 0, لأنه هي give us the sites present over the surface. So he directly correlated to our substrate. So theta I common between all these factors. So here 1 plus. If we look on the others here, we'll find common factor اللي هو c, and here we have x plus x2 plus xi. All these are equal to 1. If we want to consider, if we consider these if we consider this x plus x2 plus xi, it's a geometric progression. And this, if you remember, xi, it's x plus x2 plus xi, it's xi factorial, which is equal to x over 1 minus x. So if we replace xi factorial by its value, here we will have theta 0 equal 1 over 1 plus cx over 1 minus x. So it's equal 1 minus x over 1 plus 1 minus x plus cx, so equal 1 minus x over 1 plus x c minus 1, and this is the value of theta 0. Okay. So here we have now theta 0 as function of x and c, and as x is not or cannot be determined easily, and thus theta 0 cannot be determined easily, and the others theta 1, theta 2, which are dependent on theta 0, it will be difficult also to determine their values. So the BET scientists try to correlate as Langmuir their factors to the volume. So if we consider Vm, Vm is the volume needed of the adsorbate to form one adsorbed layer. So now the volume Vi is the volume of adsorbate, the gas adsorbed, to form I layers. So if you wanna, Vi is the volume of adsorbate to form I layers. So Vi, it's equal to Vm. It's the same, we have the same substrate and we are covering layers over others. So we need Vm, and we are repeating this I times, and this also depends on the sites where adsorption could take place. So Vi, it's Vm times I times theta I. And V, if we consider V, the total volume of gas adsorbed, so of the adsorbate. So V, it's equal to the summation of all Vi. So it's equal to the summation of I, Vm, theta I. Now if we put each of these factors by their values, so V equal Vm, it's common constant, so 0 theta 0 plus 1 theta 1 plus 2 theta 2 plus I theta I. And if we replace each of these theta by their values, so we have Cx theta 0 plus 2Cx squared theta 0 plus I C x I theta 0. So here, if I consider V over Vm, which is my coverage, if you remember from Langmuir, it's equal to C x theta 0, which is common in all these factors here, 1 plus 2x plus 3x2 plus I x I minus 1. Now also we have another geometric progression. If we consider here x factorial 1 x over 1 minus x as r, so here we have this geometric progression is dr over dx, so it's equal to dx over 1 minus x as function of dx, and this is equal 1 over minus 1 x squared. So now v over vm equal cx theta 0 times 1 over 1 minus x squared, and if we replace theta 0 by its value, it's become equal to cx 1 minus x over 1 plus xc minus 1 times 1 over 1 minus x squared. So v over vm, which is my coverage over the surface, it's equal to cx 1 minus x 1 plus x c minus 1. This is the formula of v over vm. So in this formula we don't have any more theta 0, but we still have x, and we said that xx is not easy to be determined, so science trying to find a way to remove x or to replace x by other factors. Each time they have to do something, they have to call back their assumptions. So if we go back to the BET assumptions, they said at saturation pressure they have infinity of layers of the adsorbed gas which are condensed over the substrate. So if we want to use this assumption, what we can get, I want to use another slide. Insert new slide. Okay, so at saturation we have P equal P0, and at this point they have infinity of layers. So if we have infinity of layers over the surface, what does it mean? If we look over our coverage is V over Vm, which is dependent of C and X. So to have infinity of layers means V over Vm tend to infinity of coverage. لتكون هيدي ال V over Vm infinity, ال X هون must be equal to 1. So if X equal to 1, 1 minus X equals 0, and thus V over Vm tend to the infinity, and we have infinity of layers. So we want to use this assumption. So as you remember, X is Ki over Ki desorption times P. When we have saturation, to be able to have saturation, X should be equal to 1. So 1 equal K adsorption of K desorption, and at this point we have P equal P0. So if we make the ratio of these both X and 1, we will have X equal P over P0, which is known as relative pressure. Now if we replace X by its value in the V over Vm formula, V over Vm will be equal to Cx, so C times P over P0 divided by 1 minus X, 1 minus P over P0, 1 plus X P over P0, C minus 1. So here we have the relation between the coverage V over Vm as function of P over P0. Now if we draw V over Vm as function of P over P0, it will not be a linear variation, and as we see here, it's C dependent. So by increasing the value of C, the coverage increases. Why? Because C is proportional, as I said before, to delta H adsorption. So if we increase C, means already the delta H adsorption is increased, and thus we increase the coverage of the adsorbed molecules over the surface. From this isotherm, we need to determine the value of C, and we need to determine the value of Vm, and as here, by drawing V over Vm as function of P over P0 is not linear, so we have to rearrange this formula to have linear variation. So to rearrange the coverage as function of P over P0, let's try to take this factor over V. So if we consider P over P0 over 1 minus P over P0 times 1 over V, it will be equal to 1 plus P over P0 C minus 1 divided by C Vm. So P over P0 minus P times 1 over V equal 1 over C Vm plus C minus 1 over C Vm times P over P0. And this is the development of BET isotherm, where we can get linear variation if we draw P over P0 minus P times 1 over V as function of P over P0. Here we'll get thus linear variation, where the intercept it's equal to 1 over Vm times C, and the slope equals C minus 1 over Vm times C, and by this way we'll be able to determine C and Vm. And this is the development of BET isotherm. So you need to know this formula, and you know how to be able to draw a linear variation, leading you to determine the value of Vm, which is the volume of adsorbate to form one layer over the adsorbent, over the substrate, and C, which is the BET parameter, and which is directly dependent on delta H of adsorption. So if we determine the value of C, we'll be able to determine the value of delta H.